Yes, welcome you all for another presentation on operational amplifier. In today's presentation, I would like to explain you about the relationship between the common mode input voltage to the differential input voltage to the operational amplifier, right? Let us see the difference between the relation otherwise between the common mode input voltage and to the differential input voltage. So that can be explained in detail with the help of the op-amp block diagram. So let us consider this diagram, means op-amp diagram, right? So these are the two input terminals of operational amplifier, because the plus and then minus are the two input terminals, whereas this is output terminal V0, right? Let us call it as V1, and this you can call it as V2, right? So V1 is the input voltage given to the minus terminal, whereas V2 is the another input terminal which is applied to the plus terminal, and then obviously it needs two power supplies. Those you can treat it as plus VCC, and then you can term this as minus VCC, right? This is the basic op-amp, and this is your output terminal. And always remember the pin numbers also. This is pin number 6, your output, and minus terminal is the pin number 2, and 3 is given the pin number 3. If you compare this particular with your pin diagram of op-amp, right? Now I am going to give the relation between common mode input voltage. So let us consider the common mode input voltage, that is called as VI. VI is the input voltage, and if you denote this D, suffix D, if you write like this, VI suffix D, nothing but this is the differential input voltage. VID is the differential input voltage. This you can call as differential input voltage, right? This is the differential input voltage. What is VID, by the way? VID is nothing but the difference of between input signals, that is considered at here actually at input stage, VID. And by the way, what actually the op-amp will do, the operational amplifier will takes or will consider the difference between the applied input signals. Obviously, so there are two input signals V1 and V2, therefore the op-amp will consider the difference of these two, means that V2 minus V1, that is the difference signal at the input, and that difference signal will be amplified by this amplifier, and then correspondingly the output will be generated or the output will be provided. That is what the main function of op-amp. So it amplifies, it considers the difference signal actually, right? So what is the difference signal? So it is VID is nothing but, VID means differential input signal is nothing but the difference of input signals. Those are V2 minus V1, right? That is nothing but V2 minus V1. If you differentiate, if you take the difference, differential is nothing but the difference of V2 and V1, right? So that is what the differential input. Okay, now call this as equation number 1. That is whatever differential input voltage. Similarly, if you indicate VI suffix CM, let us say CM, means that this is the common mode input voltage. VI, so okay, CM is nothing but common mode, right? Common mode input voltage, common mode input voltage. So what is the expression? Common mode input voltage is something like this. So here I think this is not required. I will erase this diagram now because the expressions are the important. Already we need the expression for what is VID and then what is VICM. Those two are the very important equations, okay, obtained from this diagram. So VID we have seen. now I am writing here VICM means common mode input voltage that is given by, it is nothing but it is the average of input signals. It is the average of the input signals. What are the input signals, by the way? V1 and V2 are the input signals. Okay. If you take V1 plus V2 by 2, that is the average of the input signals. Right. This is the equation number 2. Now, from this equation number 2, what you can write, So, from this, take the cross multiplication here. Then, obviously, it is V1 plus V2. This can be written as V1 plus V2 is equal to, right, 2 into, is it not? 2 into VICM. This is the third expression, right? From equation number 2, just I can rearrange this equation number 2 like this, because 2 times VICM is equal to V1 plus V2. Now consider equation 3 and then equation 1. From equation 1 and then equation 3, it is V1 plus V2 is equal to 2 times VICM. It is V2 minus V1. It is minus V1. Okay, V2 minus V1. Here V1 plus V2. What can be done here? If you add these two, equation 3 and then equation 1, if you add these two, then definitely what will be done? What will happen? So this V1 and then minus V1 will be cancelled out actually. So that is what my third step. So now by adding, you can write like this, by adding equation 1 and equation 3. By adding equation 1 and equation 3, what it will come actually? So this is nothing but I can show you here what will come if you add these two equations. Let us see. So it is, I can write like this. What is the first equation? V2 minus V1 is equal to VID, differential input voltage. That is first. What is the second? This one. I mean the third equation. It is V1 plus V2. Or conveniently you can write like this also. Conveniently you can write like this also. You can write V2 first plus V1 also is equal to 2 times common mode input voltage. Right? These two are I am adding now. These two equations I am adding. Now I can erase this. It is not required now. Right? So what you will get here by adding this equation 1 and then equation 3. So if you add these two, what you will get, means that minus V1 plus V1, these two will be cancelled out. What will remain here? 2V2. 2 times V2, because V2 plus V2. 2 times V2 is equal to, you will get here VID, I mean differential voltage, plus 2 times VICM, common mode voltage, right? And this is what you will get by adding those two. And from here, from this equation, V2 can be written as, this implies, what V2 can be written? V2 is equal to, take this to the right side, then definitely it is, what you will get? It is VID by 2 plus, if you take this to the right side, 2 by 2. So this goes to denominator part, therefore this 2 will be cancelled out. You will get VICM. Okay, so this is what the expression for V2. This is what the expression for V2. Or I can write conveniently here, V2 is equal to, this I can write like this, VICM plus VID by 2. I can write in convenient form like this also. Right, this is very, very important equation. V2 is equal to common mode input voltage plus differential input voltage by 2. Right. So just for convenient, so VICM I am writing first and then V plus ID by 2 I am writing like this. This is what V2. This is the voltage V2 in terms of common mode input voltage as well as the differential input voltage. This is what V2. So by substituting these particular equation either in equation 1 or in equation 3, you can obtain the expression for V1. Right. So now what I will do, you can substitute that V2 value in equation 1. Right. So now you can give some number to this if required or not. Okay, now you can by applying the above V2 or the above value of V2 in equation number 1 or 3, no problem. Means that what, wherever V2 is there, you simply substitute this much here in place of V2. Therefore, what you will get then definitely from equation 1, this is the equation 1, no? From this, what I can write, VID is equal to, I can write like this, VID is equal to V2. What is V2? V2 is nothing but this much. VICM means common mode input voltage plus VID, it is by 2. This is what V2 minus V1. So from this actually what I need to write is that I need to have expression for V1 from this expression. I need to derive, I need to bring the relationship for V1. I want to bring the relationship for V1. So what can be done for this? Very simple. So from this expression, just you bring this V1 to left side. That is nothing but you can bring this V1 here. Then it is V1 is equal to, what you will do? You simply take this VID to the right side. Then what you will get? VICM common mode input voltage plus VID by 2, right? Keep that as it is. Minus will be there obviously. So minus will be there. In V1 place you can write VID, because this VID I have to bring to the right side. This V1 I am bringing to the left side. So if you do that, you will get this expression. From this, what you will write? What you will get from this? This is nothing but VICM. So it is VID by 2 minus VID. What you will get? 2 times means obviously we will get minus sign here. It is VID by 2, because it is 2 into 1, 2 means 2 times VID, means VID minus 2 VID by 2. So it is minus VID by 2. This is what your V1. This is the expression for V1. This is very, very important relationships these two are. So by these two equations, what I want to convey is that, so let us see, these two I can compare by drawing that particular op-amp equation, I mean diagram. So this is what your V1, and here just I denoted as V2, right? This is what your output V now, obviously plus VCC, and then it is minus VCC, right? Means that what? So now I have derived the expression for V1 and V2, the values of V1 and V2 in terms of the differential input as well as common mode input voltage. What is the common mode? Common mode is nothing but applying the same signal at both the input terminals of the op-amp. That is what common mode. Applying the same input signal at both the input terminals, then that is called common mode input. Otherwise, if you apply the two different input voltages at these two terminals, then it is called differential input voltage or differential, right? Therefore, so what is the value of V1? What is the value of V1? Your V1 is equal to this one now. What is this V2? This V2 is nothing but this is the expression for your V2. Means that your input voltages in terms of the differential input as well as common mode input voltages. These are the expressions. So sometimes in examination it will be asked to find out the values of V1, V2. It will be given, the differential input will be given as well as the common mode input voltage value also given. Then sometimes you will be asked to find out what is V1. What is V1 is nothing but common mode input voltage minus differential input voltage by 2. Right? So it is V1. V1 is obviously is applied to the minus terminal. Therefore, as you have minus, remember that the minus sign will come between common mode and then differential mode. Likewise, you have to remember. So first the common mode voltage will come actually minus VID by 2. Minus because, so this V1 is applying here minus terminal. Similarly, if you remember this V2, as the V2 is applied to the positive terminal. So if you see this particular expression for V2, it is VICM plus. So because here plus is there, that's why you will get the plus. And similarly, the same expression like V1, the same exact equation, but instead of minus, you will get plus there. Therefore, common mode input voltage plus differential voltage by 2. It is very easy to remember, but very important relationships. Therefore, this gives very important information to us that so the input voltage values, the relations otherwise for V1 and V2 in terms of the common mode voltage and then differential input voltage. This is one of the very important relation that need to remember, right? So with this, I finish off this particular today's presentation, and we will see the subsequent interesting topics with the previous questions also in the coming presentations. I hope you understood this topic very well. If so, then please do not forget to give your valuable suggestions and feedbacks and comments, and do not forget to share this information to your friends and colleagues and relatives wherever they are, so that the most of the students definitely should get benefit of it. Okay, so till then, have a wonderful day.